Hi guys, today we are learning how to compare patterns and relationships with multiple representations. Our learning target for today is to be able to identify additive and multiplicative relationships when given a situation using verbal descriptions, tables, graphs, and equations. First, we'll look at how to identify additive relationships. On the right, our situation states Owen was 2 years old when his sister Greta was born. Down below, we see a table. It says that Owen was 2 when Greta was 0. Owen's age is 3 when Greta is 1. We can figure out the pattern to get from Greta's age x to Owen's age y. If we add 2 to Greta's age each time, we get to our value for y. So we know this is an additive relationship because we're adding 2 each time to get to y. Down below, we see the graph, and we can plot some points. I see the point 0, 2. I see the point 1, 3, 2, 4, and each time we're taking Greta's age x and we're adding 2 to get to Owen's age y. So from this graph, we know that it is an additive relationship. We also know it is an additive relationship because when it enters quadrant 1, on our coordinate plane, it's entering on the y-axis. So we know we need to add 2. Our equation is written below, and we know from our equation y equals x plus 2, this is additive because we're adding. And our statement or description would read, the value of y is 2 more than the value of x. Now let's look at a few more descriptions. Miles is 4 years older than his sister. So we would state this as the value of y is 4 more than the value of x. Miles' sister's age would represent x, and Miles' age would represent y. So if he is 4 years older than his sister, to get to his age, we could add 4 each time. And in our table, his age would be 6 when his sister is 2. His age would be 9 when his sister is 5. And his age would be 11 when his sister is 7. Our next description states Jeremy has 6 more cookies than Mary. If he has 6 more than, that means we need to add. So the value of y is 6 more than the value of x. Now let's identify some additive relationships from equations. Up above, we see y equals x plus 6. We know this is an additive relationship because addition is the operation in our equation. So we would state this equation as the value of y is 6 more than the value of x. Down below, we see the equation y equals x plus 3. Again, we see addition as the operation, so we know this is an additive relationship. We can state this equation by saying the value of y is 3 more than the value of x. Next, we'll identify some additive relationships from tables. Looking at the table on the left, I see a pattern. If we add 2 to x each time, we will get the y value. So in our description, we would say the value of y is 2 more than the value of x. And if we were to write an equation for this relationship, we would write y equals x plus 2. In our table on the right, the pattern is to add 5 to get to y. So the description would read, the value of y is 5 more than the value of x. And we can write an equation for this table as well. Y equals x plus 5. Last, we'll identify some additive relationships from graphs. In the graph on the left, I see points that are already plotted. I can use those points to figure out what the relationship is between my x values and my y values. I see the point 2, 5. I also see the point 3, 6. And 4, 7. Each time we're adding 3 to the x value to get our y value. So the value of y is 3 more than the value of x. And our equation would be y equals x plus 3. In our graph on the right, again, we see some points that are already graphed for us. We see 2, 3, 3, 4, and 4, 5. Each time, we're adding 1 to the x value to get our y value. So the value of y is 1 more than the value of x. Now we'll learn how to identify multiplicative relationships from descriptions, equations, tables, and graphs. Our situation on the right reads, on average, it takes 2 minutes to complete each math problem. From my situation, I know that the word each is an indicator that I would need to multiply. So looking at the table down below, if we look for a pattern between x and y, we can multiply by 2 each time to get from x to y. So our pattern is to multiply by 2, so that means we have a multiplicative relationship. In the graph, I see some points that are already plotted. I see 0, 0, 1, 2, 2, 4, 3, 6, and 4, 8. Each time, we're multiplying x by 2 to get to our y value. So this would be a multiplicative relationship. Down below, we see the equation, y equals 2 times x. Since our equation has multiplication in it, we can identify this as a multiplicative relationship. And our description down below would read, the value of y is 2 times the value of x. First, we'll identify multiplicative relationships from descriptions. Our description reads, Michael has baseball practice 4 days each week. The word each means to multiply. So the value of y is 4 times the value of x. In our table below, x represents the total number of weeks that Michael practiced, and y represents the total number of days that he's practiced. So our pattern would be to multiply by 4 each time to get to our y value. So if Michael practiced for 2 weeks, he practiced a total of 8 days. If he practiced for 5 weeks, he's practiced a total of 20 days. And if he practices for 7 weeks, he practices a total of 28 days. Down below, we see Jeff rents 6 movies per month. The word per means we need to multiply. So our description would be the value of y is 6 times the value of x. Next, we'll identify multiplicative relationships from equations. The equation up above reads y equals 3x. Our x value is being multiplied by 3, so this is a multiplicative relationship. In our description, we can write the value of y is 3 times the value of x. In our equation down below, it reads y equals 6x. Our x value is being multiplied by 6, so we have a multiplicative relationship. The value of y is 6 times the value of x. Now we'll identify some multiplicative relationships from tables. In our table on the left, we see a pattern. If we multiply by 2 each time, we will get our y value. So in our description, we could say the value of y is 2 times the value of x. And our equation would be y equals 2x, or 2 times x. In our table on the right, the pattern is to multiply x by 5. So our description would be the value of y is 5 times the value of x. And our equation would be y equals 5x, or 5 times x. Last, we'll identify multiplicative relationships from graphs. In our graph on the left, we see some points that are already plotted. I see the point 0, 0, 1, 3, 2, 6, and 3, 9. Each time to get from x to y, we're multiplying by 3. So our description would be the value of y is 3 times the value of x. And this would be a multiplicative relationship. The equation would read y equals 3 times x, or 3x. I also noticed that the graph goes through the point 0, 0. Whenever it goes through the point 0, 0, we know this is a multiplicative relationship. In our graph on the right, we see some points already graphed. I see 0, 0, 1, 4, and 2, 8. Again, I see this graph goes through the point 0, 0, so I know it's a multiplicative relationship. I also see the point 1, 4 and 2, 8. Each time we're multiplying by 4 to get to our y value. So the value of y is 4 times the value of x. Now you will complete some independent practice on your own. Remember to ask for help if you have questions.